Hello, and welcome back to Homework Help for Math 2. Today we're going to be looking at Chapter 6, Trigonometry, Lesson 1, the Pythagorean Theorem. So, question number 1 says, below is a quadrilateral drawn on the coordinate plane. Find the length of each side to determine the perimeter of the figure. And so we have this random quadrilateral. It looks almost like a trapezoid, but I'm pretty sure it's not actually a trapezoid. But we got this random quadrilateral. We want the perimeter. The perimeter, as always, is just the sum of all of the sides. So all I really need to do here is just find the length of AB, BC, CD, and AD, add them together, and we are good to go. So I'll start with AB. Notice that AB is the hypotenuse of that triangle that I just drew. Okay? And so, because AB is the hypotenuse of that triangle, if we're able to figure out the sides of the legs, the lengths of the legs of that right triangle, we should be able to solve for the hypotenuse. Well, the horizontal leg has a length of 3, and this is a right angle. And the vertical length has a side of, or the vertical side has a length of 4. And so now I can just apply the Pythagorean theorem. I know this says perimeter. We're just going to make some space for us. So we're finding AB, and the Pythagorean theorem says that the sum of the squares of the legs of the hypotenuse is equal to, or of the right triangle, sorry, is equal to the square of the hypotenuse. So I want to solve this equation for x. So I'm going to flip it around so that my x squared is on the left. And then the other side of the equal sign, well, that's just a number, 3 squared plus 4 squared. You could either go to your calculator and type it in, or just kind of do the steps individually. 3 squared is 9, 4 squared is 16. You add them together and you get 25. I want to get x, so that means I need to find the square root of both sides to get rid of that squared. So the square root of x squared is just x equals. Now, if this were purely an algebraic question, like just with no context, you would need a plus or minus right here, because when you take the square root like this, you need to account for the fact that x could have been positive or negative. However, because we're talking about distance here, you don't need the plus minus, and you shouldn't include the plus minus because distance is positive. So in this case, we're not going to include the plus minus, and we're just going to write the square root of 25, and the square root of 25 is 5. Just like that. So the length of AB is 5. Okay. We'll continue on. This time for BC, our right triangle is here. And again, BC, the thing that we're looking for, forms the hypotenuse of that right triangle. So let's figure out what the lengths of our legs are. The vertical length is 5. And the horizontal length, if you count up the boxes, you should get 12. And now we're solving for that hypotenuse right there. So legs of 5 and 12. So we're looking at BC now. And for BC, again, the Pythagorean theorem says that the sum of the squares of the legs of the hypotenuse, or of the triangle, I keep saying that, is equal to the square of the hypotenuse, which I don't know, which I again have labeled as x. I probably shouldn't be using x multiple times. Let me go up and we'll just change that to a y, I suppose. Even though I've erased the x from before, try to have good mathematical habits here. All right, so now we just got to solve for y. Again, I'm going to flip it around so that the y squared is on the left. 5 squared is 25. 12 squared is 144. You add them up and you get 169. Again, to get y by itself, we want to take the square root. So that's y equals. We don't want the plus minus because distance is strictly positive. And the square root of 169 is 13. So the length of BC is 13. Quick side note here. If you're familiar with Pythagorean triples, 3, 4, 5 in the case of AB is one Pythagorean triple, and 5, 12, 13 is, in the case of BC, is another Pythagorean triple. You tend to see those combinations pretty frequently. All right, CD. So for CD, we're talking about this triangle right here with CD, with CD as its hypotenuse. Got a right angle. My horizontal distance is 3, and my vertical distance is 7. So, go back. See if I can say it correctly this time. The Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse, which in this case we'll call z, or z if you're British. So z squared equals 3 squared is 9, 7 squared is 49, and 9 plus 49 is 58. Again, I want the square root to get rid of the squared. So we get z equals. Now, unlike the first two, the square root of 58 is an irrational number. If you go to your calculator and you type in the square root of 58, you're going to get some wacky decimal. And I think in this case, let's go ahead and I guess we'll get the decimal. I'm not sure if it's strictly necessary, but calculator is right here. So square root of 58 is approximately 7.6. So z is the square root of 58, which is approximately 7.6. And I guess because we're finding perimeter, I guess it makes the most sense to go with the decimal. If you wanted an exact answer, you would need to keep the square root of 58. But because we're going to be adding all of these numbers together, I think it makes sense to go with the decimal. The directions were a little unclear. So I'm just going to say 7.6, which is an approximate answer. And last but not least, AD, which is this triangle right here. And my vertical leg is 2, and my horizontal leg is, what is that, 6? And we're looking for, I guess, W. So we're finding AD. Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So W squared, 2 squared is 4, 6 squared is 36. You add them together, you get 40. Now, again, the square root of 40 is, again, an irrational number. Now, if you know how to simplify square roots, it turns out that this is 2 root 10. However, if your teacher is not requiring you to simplify square roots, then you can keep it as the square root of 40. And again, I think getting a decimal is probably a good idea here. I'll just, instead of bringing it up, I'll just do it on my, real quick on the side here, 6.3. So this is approximately 6.3. And again, because we're going to find the perimeter, I think it makes the most sense to give the answer in decimal form. And so my perimeter is just the sum of all of them. P equals 5 plus 13 plus 7.6 plus 6.3. And when I add them all together, I get, just doing that real quick here, 6.3, 31.9. And we're not given, I don't think we're given units for this question. No, it's on the coordinate plane. So our perimeter is just 31.9. Let's see if I can make that a prettier box. So 31.9. That's number 1. All right, question number 2, find the missing side lengths. So for this one, now for each problem here, I'm not going to get fancy. I'm just going to label all my question marks as X, because you don't really want to use a question mark in an equation. I mean, you could, and those are already X. Okay, that's fine. All right. So starting in the, I keep doing that. Starting in the top right, so we know our 2 legs. We are solving for the hypotenuse. So the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So x squared equals 5 squared is 25, 13 squared is 169, and their sum is 194. So therefore x is the square root of 194. And the square root of 194 is an irrational number. And because this is just an abstract scenario, I would actually recommend that you leave it as a square root and not give an approximate answer. And this also cannot be simplified. And so our answer is the square root of 194. We'll go across. All right. Pythagorean theorem, as always, says that the sum of the squares of the legs. Now notice this time 17 and x are my legs, and that we're given the hypotenuse. So this is a little bit different. But notice that the Pythagorean theorem itself doesn't change. The hypotenuse is always by itself, whether you know it or not. In this case, we do know it. It's 19, and it's over on the right-hand side. So now for this one, so what we want to do is we actually want to evaluate. So 17 squared is 289 plus x squared. Not much we can do with that at the moment. 19 squared is 361. So all I did in my first step was just sort of evaluate each of the squareds. Now I want to get x by itself. So the first thing I got to do here is I got to get rid of that 289. So we subtract 289, subtract 289, that cancels. And so we're left with x squared equals 361 minus 289 is 72. So I take the square root of both sides, so I get x equals the square root of 72. The square root of 72 is an irrational number. It does turn out that you can actually simplify the square root. If you simplify the square root, you get 6 root 2. So And we're not going to give a decimal answer here. So if you don't have to simplify the square root, then your answer is the square root of 72. If you are simplifying square roots, then your answer should be 6 root 2. They're mathematically equivalent. The 6 root 2 is considered better, but again, if you're not simplifying square roots, then you just leave it as the square root of 72 and just move on with your life. Also, even though none of these have the little box in the corner, but we're told, oh, I guess we're also not told that they're right triangles. Well, I guess we should just assume that these are all right triangles. So we don't normally do this, but for this lesson, we are just going to assume that triangles that look like right triangles are in fact right triangles. All right. So as always, Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Again, just like the last one, in this time we are solving for a leg. We are given the hypotenuse. So therefore, we do x squared. 10 squared is 100. 20 squared is 400. Subtract 100, subtract 100, that goes away. X squared is 300. And I want the square root of that. It's strictly positive because, we're talking about length or distance. So it's square root of 300. Square root of 300 is an irrational number. If you simplify it, it becomes 10 root 3. So your answer is either the square root of 300 or 10 root 3. I guess this is part D. Pythagorean theorem tells us that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Now flip it around, x squared. This one you could just jump directly to your calculator and just do 5 squared plus 14 squared. You just do it all in like one step, and that is 221. Take the square root of both sides. X is the square root of 221. Not only is the square root of 221 an irrational number, it also cannot be simplified, and so you are left with just the square root of 221, and that is your exact answer. Part E. This one we are given the box, so this one we don't have to assume it's a right triangle. As always, Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Because we're solving for a leg, I guess technically we could do this in one step, but it's probably easier if we just do the squareds. So 4 squared is 16. 5 squared is 25. Subtract 16, subtract 16. X squared equals 9. And so x is the square root of 9. Now the square root of 9 is a rational number. It's 3. So anytime you can get a rational answer, you should, right? You shouldn't leave it as the square root of 9. So square root of 9 is 3. And that is our final answer. If you're familiar with Pythagorean triples, you may have noticed that 3, 4, 5 is a Pythagorean triple. So you quote-unquote could have answered this right off the bat if you recognize it as being a Pythagorean triple, but the practice is always helpful. Last one in problem 2. Pythagorean theorem, as always, is that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So x squared, 6 squared is 36. 10 squared is 100. Subtract 36, subtract 36. And so x, what's going on here? Why is that not writing? X squared is 64. And so x is the square root of 64. And again, just like the last problem, the square root of 64 is a rational number. It's 8. And so you should not leave your answer as the square root of 64. I don't care what class you're in. The square root of 64 is in fact 8. That's my answer. And again, 6, 8, 10 is a Pythagorean triple. It's actually just double 3, 4, 5. So if you compare 3, 4, 5 to 6, 8, and 10, those triangles are similar, and they are both Pythagorean triples. And that's question 2. Question 3. In the game of baseball, the distance from one base to the next is 90 feet, as shown in the diagram below. Determine the distance from home plate to second base. All right, so we've got a square here, 90, 90, 90, 90, and what we're looking for here, I think I'll do this in red, is we're looking for that distance right there. How far is home plate? How far is second base from home plate? Well, notice that we form a right triangle pretty easily. And that right triangle, we know both of the legs. We know that both of the legs are 90. And what we're looking for is we are looking for the hypotenuse, x. So because we're dealing with a right triangle and we know two sides and we want the third side, that means we're going to use our good friend called the Pythagorean theorem. Pythagorean theorem, as always, says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And so I just have to solve this for x. Flip it around, x squared equals 90 squared plus 90 squared is just a number, and it is 16,200. So x is the square root of that. X is the square root of 16,200. Now, it turns out that this does simplify. It simplifies to 90 root 2. However, this is a real-world scenario, right? We're talking about baseball. And because I think if you were to say that, second base is 90 root 2 feet, that's kind of weird. So I think in this context, I think it makes sense to actually give a decimal approximation. So the square root of 16,200 is approximately 127.3 feet. And again, I think because this is a real-world scenario, I think it makes the most sense to actually give an approximate answer in decimals. So it doesn't say what to round to, so we just decided to round to the nearest tenth. And it's approximately 127.3 feet. So there you go. Number 4. All right. 4 is a little tricky. 4 is probably the trickiest question in this homework assignment. So if you got tripped up by 4, don't feel bad. Because it does require sort of seeing the trick here to sort of unlocking the problem. Now, this find the missing side length, and that's x. And that is referring to this entire thing, right? That is x. This shape is a trapezoid. It's a right trapezoid. You don't necessarily need to know that in order to solve this problem, but this is a trapezoid, which means it has one pair of parallel sides, exactly one pair. And I want to find the fourth side of this trapezoid. Well, in order to answer this problem, the key to answering this problem is you want to recognize that this trapezoid, this right trapezoid, can be formed by sort of combining a rectangle with a right triangle. So I want to pause there, and I want to make sure that everyone sort of sees what I'm doing here. Is I'm taking my right trapezoid, and by drawing that altitude in red, what I've done is I've sort of separated it into a rectangle. You know, this guy, a rectangle on the left, and a right triangle on the right. So just make sure that you see that. And the reason why that's helpful is because I now know some of the things that are drawn in this picture, right? So the thing in red, the altitude, well, if this is 15, then this has to also be 15. So the thing that I just drew, I know that that's 15. Fine. And then the other thing that I know is I know that, well, if I cover up the triangle for a second, I look at just the rectangle, I know that if this is 20, then I know that this piece of the rectangle is also 20. Now 20 is not x, because x is the green side, which is more than 20. But I do know that the piece of x that's inside the rectangle is 20. So now all that I'm really missing is I'm missing this piece of green. And if I could solve for that piece, I'd be good to go, because I just take 20 and I just add whatever's there, and then that's going to be x. Well, notice now on the right, I have a right triangle, and I happen to know two sides of the right triangle. I know the 15 is a leg. I know the 17 is the hypotenuse. I am solving for, if I solve for y, that's my other leg. And then if I add that to 20, that's my answer. That's x. So I am going to, perhaps unsurprisingly, use the Pythagorean theorem to solve for y. As always, the Pythagorean theorem says that the sum of the squares of the legs, which are 15 and y, of a right triangle is equal to the square of the hypotenuse. So 15 squared plus y squared equals 17 squared. 15 squared is 225. Y squared is going to hang out for a second. 17 squared, I think, is 324. No, it's not. I don't know what that is. 17 squared is 289. And we got to get y by itself. So subtract 225. Subtract 225. Goes away. Y squared is 64. I take the square root of both sides. I don't need my negative. And y is 8. And so this piece of green is 8. Also, for those of you familiar with Pythagorean triples, you'll notice that 8, 15, 17 is another Pythagorean triple. If you can recognize those, it just saves you a little bit of work. And so x, the thing that we're looking for here, is 20, which is the piece of green inside the rectangle, plus 8, which is the piece of green inside the right triangle, giving us a final answer of 28 meters. And that is my answer for number 4. Like I said, a little tricky. If you got tripped up on 4, like I said, don't feel bad. But you want to, I think the big takeaway from 4 is that in this scenario, you want to utilize the fact that you can turn basically any trapezoid into a combination of one rectangle and either one or two triangles, right triangles. If it's an oblique trapezoid, you would have a right triangle on the left and the right. But with a right triangle, you just have a right triangle on one of your sides, and then you sort of have the rectangle. And that's sort of a handy trick in a lot of contexts involving trapezoids. So if you didn't know that before, you know it now, and just one more thing to keep in your toolbox for just math problems. All right, 5, 6, and 7 all have the same directions. So for 5 through 7, find the missing length in each right triangle, then determine the slope of the hypotenuse given that the legs of the triangle are vertical and horizontal. And this is from the original book, lesson 6.8, numbers 18 through 20. So number 5. First thing we got to do is we got to find the missing length. Again, now we're told that this is a right triangle, so we don't have to assume this. The directions say that it's a right triangle. So it says determine. Oh yeah. So find the missing side length. All right. So I'll just use an x here because I don't like using question marks in equations. I have a right triangle where I know two sides. I'm looking for the third side. That means I'm going to use the Pythagorean theorem. Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So 3 squared is 9. Now, the square root and squared are inverse operations. That's why we take the square root when you've got an x squared and you want to get rid of the squared, you take the square root because they're inverse operations. So here, the square root and the squared cancel each other out, and you're left with just 58, right? It's not 58 squared because the hypotenuse is not 58. The hypotenuse is the square root of 58. So when you square that, the square root goes away and you're left with just 58. But this is not 58 squared. So please don't make that mistake. So minus 9, x squared is 49. And so x is the square root of 49, and the square root of 49 is a rational number, which is 7. And so my missing length is 7. So this is 7 right there. Now it says find the slope of the hypotenuse. Now, technically, at least the way that this triangle is oriented, the hypotenuse, the slope looks negative to me because it's going down, like from left to right, like it's going down. So, I would say that the slope is negative. However, if you didn't put the negative in this context, I think it's fine because we're not really, well, yeah, if you didn't put the negative, I think the directions were maybe a little bit unclear as to whether the negative was necessary or not. I'm going to go ahead and put the negative, but if you forgot the negative this time, I think it's not that big of a deal. And it's not going to be a big deal in Math 2, but once you get into some more advanced topics in trigonometry, the negative does make a difference. So I think for now, if you miss the negative, it's not that big of a deal. But moving forward, you're probably going to want to remember the negative in certain contexts. That's all. Just something to put on your radar. So the slope is the change in y over the change in x, or its rise over run. So it's my vertical distance, which in this case is 7, over my horizontal distance, which in this case is 3. So the slope is, whether you include the negative or not, the important thing is that it is 7 over 3, not 3 over 7. Okay, so if you forgot the negative, it's not that big of a deal, but if you flip this and if you said 3 over 7, that is a big deal. So please make sure that you have 7 over 3 and not 3 over 7. Question 6, this time we'll go with, I'll go with x again. It's a different problem. So again, we want to solve for x. So the Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So x squared, 10 squared is 100. And when you square a square root, it just goes away, so you're left with just 116. Subtract 100, and so x squared is 116 minus 100 is 16. Take the square root of both sides, discard the negative, and you're left with 4. So my missing length is 4. Again, technically my slope is the slope looks negative because from left to right it's going down, so I would include the negative. And it's my change in y over my change in x, or my vertical distance over my horizontal distance. My vertical distance is 4, and my horizontal distance is 10. And 4 over 10 reduces to 2/5. which is also 0.4, but I would leave it as a fraction. So negative 2 over 5. All right, question 7. Question 7 is actually a repeat of 5. So if your teacher didn't say anything, then you could just do 5 again and just get your final answer. I think for my class, I'm just going to announce that this is not a 3, this is actually a 5, and that this is not a square root of 58, but in fact, this is the square root of 89. Okay, new problem. So if this is my problem, then I'm going to use the Pythagorean theorem because, again, I have a right triangle where I know two sides and I want to find the third side. So the Pythagorean theorem says that the sum of the squares of the legs, call this x, of a right triangle is equal to the square of the hypotenuse. 5 squared is 25. Square root of a square root is their inverse operation, so they just go away. So this is just 89. It is not 89 squared. Minus 25, minus 25. 89 minus 25 is 64. Take the square root of both sides, discard the negative, and so x is 8. So this is an 8, and my missing length is 8. Again, technically the hypotenuse looks like it's going down, so it's negative. And my vertical distance is 8, and my horizontal distance is 5. So if the problem was, a leg is 5 and the hypotenuse is the square root of 89, then your other length, the length of the missing leg, would be 8. But again, that's if your teacher gave you this sort of additional problem. And that is it for lesson 1.